Hi everyone, this is Mr. Cardoso. In this video I'm going to be taking up question number 2 from section 6.2, 2a, b. I might not get to the reduce method until the next video, but let's start with these two. So the first question says, complete the definitions of the following instance methods for the fraction class. Public void plus equals fraction other. The method should basically add the other fraction to the current fraction. So this was our fraction class as I left it for you last time. So I was hoping that you would actually just take this class and add to it from what I posted online. So what we're going to do is we're just going to go over here and we're going to create this method. So we've got the times method that we did last time. And right below it, I'm going to make the plus equals method. So public void plus equals, and then we go fraction other. Open and close that method. Now, again, you can see this method doesn't return anything, but it's supposed to be adding two fractions, like we're adding two fractions together. And again, the one that's going to call it is the implicit fraction. So, for example, if I go to my fraction class, it's always good to try to imagine how would I call this method. So if I go to my fraction calculator class, I should say, I'm going to simulate calling it. Right now I won't be able to run this, but the idea is how would I call this? Now since it's a void method, you can see it's void here, it's void here. It's not going to return anything. So I have to start, and it's also non-static. There's no static keyword here. So that means it's an instance method, and that means it has to be called on an instance. So two instances I have here is f1 and f2. I also have prod, but let's just stick with f1 and f2. So if I go f1 dot plus, then the name of the method, plus equals, and then in here I put f2. So that's how I would hope to call it. Now, as it's set up here, let's just use those diagrams. So we've got f1 pointing to 1 and 2, and then we've got f2 pointing to 3 and 4. So this is just some notes that I'm doing. Now, when I call this, again, it's different than these two. Notice here we did f2 dot times f1, and we had something on the left-hand side. That's because this times method, if I go back to the fraction class, has a return type of fraction. So it's returning a fraction, and that's why we store it on the left-hand side. Same thing here with the 2 decimal method. It returns a double. So if we go back over here, the 2 decimal returns the type double. But plus equals returns void. And so that's why on the left-hand side, there's nothing in this call. We actually, so if it's void, I got that question before, if the method is void, how does it actually do anything? And this is where my lesson number 5 was very useful, where it talks about pass by reference versus pass by value. I won't go over that again, but because it's void, it's actually, and because that we're passing in an object here, two objects are being passed in, the one that's the instance, the implicit one, and this is the explicit one going into other. And because it's their objects being passed through, remember they're pointers or references. So we'll see that when we go to the fraction class here now. When this method is called, just like it is here, f1 acts as the this inside here. So inside the fraction class, we have this pointer pointing to this one, and f2 is in the brackets here, so that will come in as other. So other will be pointing here. So in the fraction class, we have the handles this and other. In the fraction calculator class, we have the pointers f1 and f2, those handles. Okay, so they're pointing to the same objects, we just have different access handles or pointers to get to them. Now, let's go back over here. And so what we're actually going to do in this method, what they're asking us to do, I didn't put the whole question here, but they're asking us to basically add F2 to F1 and then put the result back into F1. And that's what the plus equals does. If you remember with integers, we did that too. For example, we could say int x equals 4, and then we could say x plus equals 3. And what that would do is add 3 to 4, and your x would be 7, right? So you're putting in the value, adding it, and then putting it back into the same variable. So here, our x would be f1. We're adding f2 to f1 and putting it in there. So what we would like to do is add these two fractions such that when it's over, when the method is done, in this example, we would add 1 over 2. So do we remember how to add fractions? I know some people in their homework actually just went, this is 1 plus 3, it's 4 over 6, and that is not how you add fractions. So hopefully you didn't do that. You have to find a common denominator here. So in our case, we're actually not going to worry about reducing it. So the simplest formula is just to multiply these two. So we get a common denominator of 8, especially when we're programming it. And then we go, well, we multiplied this by 4, so basically it's kind of like a cross multiplication. 4 times 1, and then these two get multiplied, so 3 times 2, right? Because this has to be multiplied by 2, so whatever you do to the bottom, you do to the top. And then we get 4 plus 6 over 8, which is 10 over 8, which we know, of course, can be reduced, but for now, we're not going to worry about the reducing. You notice in this question, reducing method is actually part of one of the questions. I think it's part C. So, at the end of this, our F1 and our this should be pointing at 10 over 8. That's what this should be later. So we should get rid of the 1, get rid of the 2, and it should be 10 over 8. So I'm going to erase that now. That's what we want to happen. So instead of, like in the times method, we made a new fraction to store the result. Now that's useful, like we times the current fraction with the other one that came in the brackets, but we didn't change either of F1 and F2. If you remember this, we went F1 dot times F2. F1 and F2 kept their original values of 1 over 2 for F1 and 3 over 4 for F2. They didn't change their values because this method didn't change their values. What the method did was create a new fraction, and then it multiplied, used those values to determine the num in the denominator of the new fraction that we've created, and then it returned that one. Whereas this one, we're actually going to change, so we don't have to create a new fraction. We're actually going to take this fraction, the current one, and that's what we're going to do. So in this class, the fraction class, I use the this handle, not F1. Again, F1 is only used in fraction calculator. So this dot new gets, so it's on the left-hand side of equals. That means that's the value that's going to be changed, right? The value's on the left-hand side of the equal sign. So that's going to be changed in here. And so what we're going to do for the numerator, what did we do for the numerator here? We multiplied this dot num, that's this dot num, times other dot den, plus this dot, sorry, other dot num times this dot den, right? So this dot num times other dot den, plus, so I'm basically just doing this formula over here, and then I'm going to go this dot den times other dot num. Now, so this is this formula. Basically, if you need to see it a little bit more, this is pointing right here, and other is pointing right here. So this dot num is 1. So this dot num times other dot den, which is 4. So that's why we get 4 times 1. This time dot num dot other dot den, and so on. And other is the fraction, again, the explicit fraction that's coming in. So it's this fraction right here. So now we've got the numerator, and for the denominator, this dot den, we're going to set that equal to just the two denominators multiplied together. So this dot num times other, sorry, this dot den times other.den. And do we have to return anything? The answer is no, because for two reasons. It's a void, and because we've already updated the values in the current fraction. So f1 will have changed now, will have modified. So this is you have to be very clear, and that's where the comments come in. You notice I haven't been putting the comments in here, but that's where the comments come in. You have to be very clear what you're doing. Are you creating a new one and returning that, and thereby not modifying the original operands, in the case f1 and f2? Or in this case, you have to let the other programmer who's doing fraction calculator know that you are in fact changing the operand values that they've set out. So f1 will no longer ever be the same. We will have changed f1. So I'm going to take this now, and let's just take out all of our other, just so we can test it out. So I'm going to take out that, and I'm going to do this, and then, let's just print out f1. So we'll just say f1 equals, not f5, f1 equals, and we'll print out f1, and then hopefully it's 10 over 8. So we'll compile that, and hit the run button, and you can see f1 equals 10 over 8. So f1 has been changed, right? I don't have to, it's not being returned into anything else because it's void, but because of how this works, this is on the left-hand side of the equal sign, and that's really, really important, because that means it's being changed. If the other was on the left-hand side, other.num and other.den were on the left-hand side, that means that other would be changed, and in this case, f2 would be the one that would have been modified or changed. So that's how this goes back and helps solidify what we learned in lesson 5, which was the difference between how objects work with methods and how primitive data types work with methods like ints and doubles and so on. If you passed an int into this method and then you change that int, we saw that example in lesson 5, it would have not done anything to that int over here because it copied the value and then it changed the copy. In objects, again, it is sending a pointer. So it's sending, when it sends the f1 and the f2 here, f1 is being sent to this and f2 is being sent to the other. It's sending them as pointers. So that this is pointing to the same objects. It's not copying them. It's not copying them. It's not copying them. Okay? It's sending a pointer to the same object. And so when we then change this, we are changing whatever was coming before the decimal in the the point here before in the function call. When we change the other, if we do change the other, then we're changing whatever's in the brackets in this case. And in this case, we're not changing other would have been the same. So if we print out other, it would still read out 3 over 4. I hope that makes sense. I didn't even get to the second example here with just the plus. But give that one a try. I'll come back and try the plus one and then the reduce method after that. Thanks for listening. Talk to you next time.